My name is Christopher Patterson. I am a bioresource engineering student at McGill University in Montreal, Canada. Over the course of the past several years, I've been lucky enough to have been a part of Project ATILT, that is Astrobiology Training in Lavatubes, a project funded by the Canadian Space Agency's FAST program. My role in the project was primarily focused on landing site selection for a mission proposal to explore lava tubes on Mars. These are caves that are formed through volcanic activity that we believe we can find on Mars. Our hope is that a mission like this, if performed correctly, could find evidence of life or even life itself on the red planet. Most of the observation of these potential landing sites was performed using the HiRISE orbital camera, a system that is currently mounted on the Mars Reconnaissance Orbiter. Luckily, the HiRISE camera has a database located online that the public has complete access to. When I first started with the project just a few years ago, I had absolutely no idea how to use any of these databases or any of the tools that we would require in order to perform these observations. After some gentle guidance from my PI, I settled on using Google Earth's Mars program as the springboard that I would begin my observations with. The software has a manipulable globe of Mars, with orbital imagery overlaid on its corresponding geographical locations. Using this system, I targeted known volcanic locations on Mars in hopes of finding lava tubes present on site. This would of course require working knowledge of how these formations can present themselves from orbit, and so I performed a literature review to familiarize myself with the geometry of these caves. And so after performing this process for several months on different volcanic locations on Mars, we were able to identify several sites of special interest, which we then cataloged. Of course, in the context of mission planning, simply identifying a formation of interest isn't sufficient, and so we decided that we wanted to create 3D models of the region so that we could properly identify where to put the spacecraft down. To do this, I created a MATLAB code that's able to take STL data extracted from JMars, an open source Mars observation software, and create a 3D manipulable model that we could then color code in terms of elevation and decide where to put the spacecraft on the surface. The software works by taking extracted MOLA elevation data collected using the MOLA instrument and performing triangular interpolation between the different points to create a smoothed out and manipulable surface. After all of that work, I was able to identify about 3 different landing sites that we could possibly go to, each with their own entrances to the Martian subsurface. Throughout the entirety of this project, I can very confidently say that my skills were at the level of a citizen scientist, and I had absolutely no formal training whatsoever to perform these observations. But because of that, I can conclude that with enough time, dedication, and perhaps a gentle guidance, citizen scientists can very effectively perform orbital observations on really any planet that they want.